Open A-CODE and Cline side by side. Give them the same repository, the same model, the same prompt, and the same bug. You would expect the token build to be pretty similar. After all, the intelligence is coming from the same model. But that is not necessarily what happens. Because when you use an AI coding agent, you are not paying only for the model's answer. You are paying for everything the agent decides to show that model. Files, repository context, terminal output, previous messages, tool results, plans, failed attempts, and sometimes the same information again and again. A 2026 study of agentic coding found something pretty wild. The same task could vary by as much as 30 times in token usage between runs. And another benchmark found that simply changing the agent harness around the same model could dramatically change how much compute was spent without necessarily producing a better answer. So I wanted to test a much more practical question. A-CODE versus Cline. Which one actually burns more tokens? And more importantly, why? To understand the result, you first need to understand that these two tools look similar from the outside, but they manage a codebase very differently. Start with A-CODE. A-CODE is extremely Git-centric. Instead of behaving like an agent wandering around your repository, it tries to give the model a compressed picture of the project. It calls this the repository map. The repo map contains important files, classes, functions, signatures, and relationships between them. A-CODE ranks those pieces using the structure of the codebase, then tries to fit the most relevant information inside a token budget. By default, that map targets roughly 1,000 tokens, although it can expand when A-CODE needs more information. That matters. Imagine a repository with 2,000 files. The model probably does not need to read all 2,000 files to change one authentication function. A-CODE can essentially say, here is the map, here are the important symbols, here is the file we are editing. Now solve the problem. That is a very different strategy from continuously discovering the repository through tool calls. And this is where Cline comes in. Cline is much more agentic. A Cline task builds a working context containing your prompt, conversation history, files it has read, command outputs, tool results, and its own instructions. It can search the project, read another file, run a command, see an error, read another file, edit something, run the test, inspect the failure, then try again. Every one of those steps can mean another model interaction with more context carried forward. And this is both Cline's biggest strength and potentially its biggest weakness, because autonomy costs tokens. Suppose both tools need to fix the same bug. A-CODE might already know from its repo map that auth service calls token manager and that the relevant method lives in another file. Cline might discover that relationship itself, list the directory, search for the class, read the file, follow the import, read another file, run a test, then edit. That exploration can make Cline much better when you do not know which files matter, but every step has a price. Cline even warns about this in its documentation. Its context grows with file contents, commands, and conversation history, and it recommends using .clineignore to stop irrelevant dependencies, generated files, and build artifacts from entering the context. Their documentation shows that in extreme cases, good ignore rules can reduce a starting context of more than 200,000 tokens to below 50,000. So this comparison needs rules. Same repository, same commit, same model, same provider, same reasoning settings, no MCP servers, no browser tools, no hidden extra instructions, clean git state before every run. And 4 tasks. First, a tiny bug fix. Second, a multi-file refactor. Third, a new feature. And finally, a change inside a much larger monolithic codebase. For every run, I measured total input and output tokens, cache tokens where the provider exposed them, API cost, total time, number of model calls, files touched, and whether the test actually passed. Because there is another trap here. More tokens does not automatically mean more money. A cache token can be dramatically cheaper than a fresh token depending on the provider. So if Cline processes more raw tokens but repeatedly hits cached context, its actual bill could be closer than the token counter suggests. And A-CODE also supports prompt caching. With supported providers, A-CODE can cache pieces such as its system prompt, read-only files, repo map, and editable files instead of paying full price to process the same prefix repeatedly. So I tracked both, tokens and dollars. Before running my own 4-task benchmark, there is one result I can put on screen without inventing data. In A-CODE-CLI Task 6, both agents used Claude Sonnet 4.6 on the same helpdesk application task. The reported numbers were these: Aider used 1,000 input tokens and 18,000 output tokens for 19,000 effective tokens in total. It took 236 seconds, reached 13.3% on the back end and 75% on the front end. At standard list prices, that is roughly 27 cents. Cline used 76,000 input tokens and 40,000 output tokens for 116,000 effective tokens in total. It took 548 seconds, reached 60% on the back end and 75% on the front end. At standard list prices, that is roughly 83 cents. Those cost figures are simple estimates using Claude Sonnet 4.6 standard list prices of $3 per million input tokens and $15 per million output tokens. They are not the benchmarks provider invoice and do not reconstruct cache reads or cache writes. Cline used about 6.1 times as many effective tokens and took about 2.3 times as long. At first glance, that looks like an overwhelming efficiency win for Aider, but both agents reached the same 75% front-end score, while Cline reached 60% on the back end and Aider reached only 13.3%. The important behavior difference was not simply how much context each agent consumed. Cline spent substantially more context and time, but that extra work coincided with completing much more of the back-end task. This external result is not a substitute for my planned small bug, multi-file refactor, feature, and monolith runs. Those 4 rows should only be presented after fresh controlled measurements from the same clean commit, provider configuration, cache policy, and hidden test suite. And this is where I would stop calling token efficiency a simple leaderboard. Because an agent that uses 80,000 tokens and produces a working feature can be cheaper than an agent that uses 40,000, fails, and makes you start again. Recent research on coding agents actually found that spending more tokens does not reliably produce higher accuracy. Performance often improves up to a point and then saturates, while token consumption keeps increasing. The planned monolith test is still the most important follow-up. Large repository, lots of files, dependencies everywhere. Exactly the kind of project where people worry that an AI agent will inhale the entire codebase and destroy their API budget. This is also where the architectural difference should become obvious. Aider tries to compress the repository. Cline tries to investigate it. Until that controlled run exists, the honest on-screen result is not measured yet. The external helpdesk benchmark gives us a strong hypothesis, not a universal winner. There is one more Aider setting that can completely change these numbers. Architect mode. Normally, Aider can use one model to reason and edit, but in architect mode, your request first goes to an architect model to design the solution. Then Aider sends that proposal to an editor model, which converts it into actual file edits. 2 stages, potentially better reasoning, but also 2 model requests. Aider's own documentation explicitly warns that architect mode can take longer and increase costs. So saying, Aider uses fewer tokens than Cline without mentioning the configuration is almost meaningless. The same is true for Cline. Plan mode adds planning, subagents add separate context windows and their own token budgets. MCP tools add more results, browser usage adds more context. Long-running tasks eventually need context compression. Cline's auto-compact feature actually performs another model call to summarize an overflowing conversation before continuing. This is why comparing coding agents only by the model name is becoming increasingly useless. Claude inside Aider is not the same system as Claude inside Cline. The model may be identical. The harness is not. One system decides what files to read, another decides what context to preserve. One sends a compact repository map. Another performs tool calls to discover the project. One may use 2 models. Another may spawn subagents. The model is the brain, but the harness decides what the brain sees and how many times you pay it to look. So which one burns more tokens? In theory, I would expect Aider to have the advantage on focused coding tasks where the relevant code can be represented efficiently by its repo map. Cline has more opportunities to accumulate token usage because its normal workflow is more exploratory and tool-driven. But that is a hypothesis from their architecture, not a universal rule. A complex task can reverse it. Aider can miss context, require more files, retry and edit, or use architect mode. Cline can spend more upfront, understand the problem correctly, and finish without rework. And caching can make the tool with more raw tokens cheaper on the actual invoice. That is probably the most important thing I learned from this comparison. The question is not which agent uses fewer tokens. It is how many tokens does the agent need to produce one successful change? Because developers do not buy tokens, they buy working code. If Aider finishes your task for half the tokens, that efficiency matters. If Cline spends twice as much but solves a problem Aider cannot finish, the extra tokens were probably worth it. Same model, same repository, same task, completely different bill. And the difference is not necessarily the AI, it is everything wrapped around it. If you want me to test another pair, Claude Code, OpenCode, RuCode, or something else, leave it below. Because the next AI coding benchmark should not only ask which agent writes the best code, it should ask how much intelligence you had to buy to get there. And I will see you in the next one.